Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first, a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars and we will do our best to respond to all of them in real time, but I want to provide an additional mechanism to ensure any questions we miss get answered. If you'll visit aka.ms Azure Sentinel / Azure Sentinel community, you'll be able to ask questions on our Azure Sentinel forum. If you're listening to this after the fact as a recording, that's a great place to ask a question. We always love to hear your feedback on whether these webinars are valuable to you and how we can improve them. So you can give it to us at aka.ms/security webinar feedback. And all these links I'm referencing here are in the IM window for your convenience there. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security webinars. While you are there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for at aka.ms/security private preview, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a great topic for you today. We'll be talking about Azure Sentinel. Specifically, we'll be focusing on architecture, both for the cloud and on-prem. I'd like to introduce you to our presenter, Ofer Shazaf. He's a principal program manager on the Azure Sentinel product team, so he has deep expertise in this topic. Without further ado, I will turn it over to him. Ofer? Ofer, we got you still on mute. Ofer, you're still on mute.
I'm better now.
Better now. Gotcha. Thank you.
Yeah. Sorry, everyone. I did mention, now that you can hear me, that we'll spend the next 90 minutes talking about a Sentinel architecture, Azure Sentinel architecture. It's a part of a series. Azure Sentinel is a SIEM product. There is a lot to learn about it, and we are holding a number of webinars. The first one was last week. The recording is already available in the URL that Ryan mentioned, and it was about the basics. It was a deep dive, but if you want to learn about the product, go and visit the last week's webinar. As Ryan mentioned, today we'll focus on a more advanced topic and we'll talk about architecture. After the holidays break, after everybody enjoys some vacation, we'll be back with additional webinars. One of them will be about the end-to-end SOC scenario, which will be more targeted towards analysts and security people rather than architects, and we'll show you how to use Sentinel in real life SOC to detect, triage, and investigate incidents, and lastly, respond to them. And lastly, we'll get back to a topic we've been through earlier in September, threat hunting using Sentinel. We're also working to schedule additional webinars, so keep tuned. Without further ado, Azure Sentinel architecture. We have two large topics today to discuss. In a way, when preparing the slides and preparing for this presentation, I thought that it might be too much for a single webinar. And I'll try to make sure that we cover as much as possible and hopefully in a way that would be useful to you around both topics. I may cut a few areas a bit short to make sure that if you came to hear about cloud, you learn, and if you are more interested in on-prem collection, you also get the information you need. As Ryan mentioned, if you have any further questions, either in the chat box or later on in the security community. And we'll start with collection. Azure Sentinel is a SIEM, Security Information Event Management solution. It's there to serve as the nerve center for your security operations center, for your SOC. The most basic functionality that has to provide in order to be that is to collect telemetry from anywhere in your IT estate. It would be cloud, Microsoft Cloud, as well as other clouds, as well as on-prem devices. Since we are dealing with security, naturally security devices are an important goal, but that's not the only source of events we want to collect data from. For example, file and email activity are very important in order to detect a large number of threats. Azure Sentinel supports all of that, and the discussion will show different ways in which you can connect sources and get events into Azure Sentinel. Largely speaking, I would divide it into cloud-based collection and on-prem collection. I think that you'll find that cloud-based collection is extremely easy with Azure Sentinel. We'll discuss how and to do that. And then I'll go into on-prem collection. On-prem collection is one of the main tasks you need to go through when you implement a SIEM. And Azure Sentinel is no exception. And we have all the tools you need for that. I would not want to claim it's simple. A lot of tools out there you want to collect from, and it requires some know-how, which we'll go through today. But I'll start with cloud. Azure Sentinel can natively collect from I wanted to say any, I'm probably missing a few, a Microsoft service, whether it's part of Azure, whether it's one of our Office 365 services, or whether it's one of our Windows services. The reason is because we are part of Microsoft Management Fabric, Azure Monitor. Azure Sentinel is a solution on top of Azure Monitor, and Microsoft mandates all service owners within Microsoft to send information to us. So even if there is no connector on the Azure Sentinel connector page which says specific service that you're looking for, good chances that if you go into the instructions for this specific service, you'll find how to send data to us. This provides a very good coverage of a cloud, Microsoft Cloud Estate. In addition, we are not a Microsoft only SIEM. We are there to provide you with solution to monitor and protect any other IT system, and that would extend to additional clouds. We already have support for AWS. Our current support, the built-in support, is for CloudTrails. We have developed a custom connector which we can work with you to implement for CloudWatch, and we are working to extend further support for AWS telemetry. An interesting thing is that since AWS is a cloud service, connectivity is also easy. We'll get to on-prem. On-prem will require more, but our collection from AWS is a cloud-to-cloud integration, which means serverless. You don't have to worry about a connector machine or scale or anything like that. You set up the connection. There is a bit more to do because there is security authentication to go through. It's all outlined in the AWS connector page on Azure Sentinel. And within minutes, you'll be connected and you'll get your telemetry from AWS. So I don't want to spend a lot on the easy stuff. It's a deep dive architectural talk. You can go to the documentation and probably get all those connected very easily. So let's move on and talk about a cloud architecture, sorry, on-prem collection. The first thing you want to collect would be telemetry from systems. And when I say systems, actually it's true for on-prem based systems, but it's also true for VMs in the cloud. So IaaS, infrastructure as a service. The best way to collect telemetry from systems with Azure Sentinel would be using our agent. Our agent can be deployed on Windows machines and on Linux machines and would collect the system telemetry, for example, Windows events on Windows or Syslog on Linux. It would also enable you to collect additional streams from those servers or endpoints, such as Windows firewalls, DNS logs from a domain controller, or DHCP logs. In general, especially when you talk about cloud readiness, using the agent is the recommended way because it can be well embedded into your DevOps cycle. So say that you have a deployment process, and it's true, by the way, for Azure or AWS, and you're spinning in an auto-scaling environment VMs, or actually it's true for containers as well. You don't want to worry about how those systems will deliver telemetry for Sentinel. You want to make sure that the image itself out of the box is deployed with the right agent to communicate and send events. That's why in the cloud, the usual methodology or best practices is to use an agent in order to send telemetry to Azure Sentinel. I think it's also this level of cloud readiness, for example, using ARM templates in order to deploy the agent on Azure, is one of the things that makes Sentinel very much cloud ready to monitor your cloud workloads. But I did say that we are talking about on-prem, and the agent works just the same also for on-prem VMs. You may notice that there is an optional collector proxy. If your VMs on the cloud or on-prem do not have direct connectivity to the cloud, you can use a collector proxy to centralize the location in which data gets out of the organization. If you don't want to do remote collection, or you want to collect from sources that you cannot install an agent on, this would be a lot of security systems that would use Syslog or common event format, which is a specialized type of Syslog, very common for sending events to a SIEM, or that you have a networking agreement that sends events using Syslog, or that you're using Linux machines but do not want or can install an agent on them, you can use a Syslog connector. We'll get into the internals of the Syslog connector somewhat later in this discussion. An interesting deployment option is to install this Syslog connector box in the cloud. It's very valuable if you're connecting, say, for a branch office where there might not be a location for a VM, or if anyways the branch office is not located close to where your main data center is, and then sending that through your on-premise center does not make any sense. The one thing you have to keep in mind is since it goes over the cloud, you will have to use encrypted Syslog over TLS. Some source devices would support it. Other source devices may not support it. In this case, deploying the collector on the cloud might still be an option using something like Azure Express Route, which is if you have some direct connectivity to Microsoft Azure. So we discussed remote collection for Syslog and for security and networking systems. You may also want to use remote collection for Windows. To collect remotely events for Windows systems, if you do not want to install the agent on those systems, you can use WEF. We can, and I'll show the internals and how you implement that a bit later on. You can use a WEF connector VM. The WEF connector VM is essentially a Windows event collector server. It uses the standard Windows event forwarding mechanism, and it knows how to forward events to Sentinel. We appreciate that many people are accustomed to other types of connectors. So we are open and we are not supporting just the Microsoft connector infrastructure. If you prefer Logstash, we support that. We have a plugin for Logstash that can send information to Azure Sentinel. It it does provide, I wouldn't say more flexibility than our connector, but certainly more people know how to customize Logstash in order to derive things such as, for example, obfuscate fields on the fly between the source and Sentinel. If you already have a collection infrastructure that would be based on Logstash, you can use Logstash and just add an additional destination, and the events will be available with Azure Sentinel. The same capability is also available for Fluentd, an alternative log processing system. My experience out there is that Fluentd is not as widely used as Logstash, hence I didn't include it in the slide. With our support for Ceph, Syslog, Logstash, Fluentd, etc., we support a large number of sources. We do use it using the traditional way, using Syslog, and as my need for a pretty elaborate architectural slide suggests, there is a cost to that, a complexity cost. A cloud native SIEM would have loved to get away without having any on-prem collectors. We don't deem that possible today. One of the main reasons is that it's hard to beat Syslog as a service, given that it would require authentication and encryption. Many source devices do not support it. It's a partial solution. Syslog in general is a protocol that does not support authentication. Hence, we would need something in between. We do have as a vision, a goal to work with partners so that they send telemetry directly to Sentinel using our API. As in, you can see, big names have already released support for that. So for several sources, and not the lightweight ones, you can already use direct connection to Sentinel. You'll go to those product UI, you'll copy two numbers from our portal, our workspace key, we'll talk about that a bit later, workspace ID, and then our secret key, and data will flow in. We believe as a vision that that's how connectivity to a cloud native SIEM should be. It's a long journey. It will take time until much of what you need today would use that method. Lastly, you'll always need custom connectors. And we have many ways in which for you to build custom connectors. We'll talk about those a bit later. One important thing I want to point out, we have the list of connectors in the Azure Sentinel connectors page is limited in length. It's not comprehensive. And we have in our community a series of blog posts which are linked in and will be linked from the PowerPoint you can download later on, which will guide you through additional connectivity options. The first one is obvious. We support generic Ceph and Syslog. I'll talk about the difference a bit more later on. So any device which can send Syslog or can send Syslog the common event format over Syslog, we can support. And this specific blog article lists those sources, and we continuously update that. As I also mentioned, Microsoft services and apps are mandated with sending information to us. We have not, in all cases, added a connector on our side. You can still usually go to the source service side and define us as a destination. The second article here would list all those services and apps. Sometimes it also extends to some services that do not that. For example, on-prem SQL Server does not send to Sentinel, but it just writes events to the Windows event log, so our normal agent can read the events. Which gets me to the third bullet. The agent has a series of capabilities. I described a bit of them, but there's more there. So the agent collection capabilities are described in the third article. And finally, if you want to write custom connectors, the fourth blog post would help you do that. One of the reasons we need those blog posts, certainly the last three, less the first one, is because Azure Sentinel is part of the larger Azure ecosystem and benefits from a lot of the underlying or integrated services, and therefore the documentation may be spread. We probably need to do better on that, but the three blog posts here have a lot of links to the relevant documentation, which might not be part of our documentation set as of today. So I described the log analytics agent, I described the collector, I described the Logstash and custom collection. Let's try to go through each one of those and understand a bit more about that. The log analytics agent. As I mentioned, you can install it on a Windows server or on a Linux system. Actually, I said Windows server, any Windows system, can be a client as well. It can be used for more than just what it can collect anything which is Windows events, and a lot of things in the Windows ecosystem are Windows events. So for example, collecting Active Directory events would be done by placing the agent on your Active Directory. You want to collect Sysmon events, that's also Windows events. We also support collecting them. And I did mention that SQL Server also logs through that. In addition to system events, Windows events or Syslog, which is the core collection for Windows or Linux respectively, we also support a few other sources, DNS events, Windows Firewall events, IIS events. The agent can collect any file data, so it can monitor a folder for new files and get those and send them as events to Sentinel. And behind the scenes internally, it's based on Fluentd, so it supports Fluentd plugins. As I mentioned before, Fluentd is a very capable technology, but it's not well known. So we find that most customers use our agent as is and do not use Fluentd plugins, though the capability is there. Another note on log analytics agent, we have used at Microsoft different names for that over the years. If you know the term OMS agent or MMA, it's the same agent. Moreover, you need just one agent for all the different Microsoft services that work off this agent. It's not a new agent. It also is GA for a while, which is more than longer than Sentinel. So it's stable and production ready. If you already have it on your systems, then collecting to Sentinel is just turning on that on the Sentinel side. Deployment. I mentioned Windows or Linux. It's very easy to add it to your automated install in Azure. For most Azure VMs, it will be there by default, or at least will be available to you through the virtual machines interface. So when you press connect, you essentially make sure that the agent is available there. It provides central management. So once you install the agent, you can install many aspects of it from a central location. And I did mention already it provides proxy support. So if your virtual machines are not connected directly to the internet, a proxy would be able to be there between them and the internet. It also supports central management. It's not just for sending events. Moving beyond the agent, let's talk about Ceph and Syslog collection, which is a core capability that's used for a lot of, it's sort of the basics of security information event management, or SIEM. Let's look at what is our collector. Our collector is a VM or a host that you can deploy, and I'll show this one is an on-prem option. And essentially, inside it has two services or two daemons, which is a Linux VM. One of them would be a standard Syslog server, the one that you'll get when you install a Linux. The other would be the same login links agent which I described just a minute ago. Together on a box, this would be the collector VM. It enables the login links agent is the piece that sends events upwards to the Sentinel workspace in the cloud. Of course, it's not by night. This is done over HTTPS. It's encrypted, and the Syslog daemon would be the element collecting or listening to the information from the Syslog sources. Okay? Together on the single box, they are our collector VM. In between them, they communicate using Syslog as well over TCP. I mentioned here the two ports because that's the difference between Ceph and Syslog. If the Syslog daemon sends data over port 25224 to the agent, it is considered Syslog information. If over 25226, it's considered Ceph information. The same collector, as I mentioned, can be also deployed in the cloud, when it works. The technology is exactly the same. The difference is that now you send Syslog over the internet rather than TLS over the internet, rather than RESTful API over TLS over the internet, and it's very good when you don't have footprint for a VM on your on-prem location, but it does require making sure that the lag between the Syslog source and the collector VM, which is Syslog, is well protected. Might not be trivial. How do you deploy this collector? So what you do to do that, and the instructions are already in the documentation in way more detail, but you deploy a Linux VM of your choice. If on Azure, because you want to do remote collection or because you collect information from Azure resources, from Azure VNet, it can be any Azure Linux VM. If on-prem, whatever Linux VM you like. There is a set of requirements set up in the documentation, but it covers most Linux flavors, as well as I mentioned the two popular Syslog daemons. Once you do it, all you need to do is run a deployment script. It's linked from the collector page on Sentinel. What the deployment script does, it installs the other element, the long list agent. It configures it and it configures your Syslog daemon. So even though the Syslog daemon was there as part of your VM installation, it's very much part of the area that we configure for you. Also later on, I will not get into details today. Through the UI for Sentinel, you can configure this collector VM, and you configure both things which are within the agent and both things which are within the daemon. They work as a single system to make sure that you get your Ceph or Syslog events. An important element to stress is that, as the diagram mentioned before, you can use a single Ceph collector machine to use any number of Ceph sources. So we'll talk about scaling and size in the next slide, but as a starting point, if you have multiple machines, you don't need to create a VM to collect from each one of those. Even if you have multiple log types, say Cisco firewalls and Palo Alto firewalls, you don't need a separate collector for it. You can use a single collector machine to collect from both, from any source up to capacity, to be discussed in a minute. You can also use sorry, more direct advanced configuration that would be outside of the scope of the deployment script and the central management by manually modifying configuration file mostly for the Syslog server, and that will enable you to do 3 additional things, probably more. The capabilities of the system are pretty significant, but 3 worth mentioning. First of all, if you do want to use the same collector to collect both Syslog and Ceph events, so sources that send Ceph and sources that send Syslog, you'll need to do some configuration changes on the collector box to enable that. You can also filter events. That might be a very important capability. You don't want everything to go to Sentinel, mostly by using the filtering capabilities of the Syslog server, rsyslogd or syslog-ng. You can filter events and make sure that you don't get too much events you don't need. And lastly, you'll have to go into direct daemon configuration to use TLS by following the guidelines for supporting TLS with the relevant Syslog server for you, rsyslog or syslog-ng. The deployment procedure I outlined before was about deploying a Ceph collector. Syslog collector, as I mentioned above, is nearly the same. The procedure outlined in our documentation is a bit more cumbersome. We did not create the same deployment script that we have for Ceph also for Syslog, but you can, and I probably need to plug about the details of that are beyond a webinar. Use the same procedure for Ceph and then modify the Ceph connector to do Syslog. Should be a small change. Scaling sizes. So our Ceph or Syslog collector is pretty capable. We scale to as much as 10K EPS using very cheap hardware. Actually, the one we tested is a specific Azure VM, which costs around $20 per month, at least in the US data center. The reason we can do that is because the processing itself is not done on the collector box, it's done in the cloud. So the collector box is essentially just a proxy. It just receives data in Syslog and make sure that it transfers that using RESTful API to the cloud. As I mentioned, you can use the same collector for a lot of sources, and 10K EPS would give you a lot of leg room for that. One question that's often asked is, how do I cluster? Clustering would enable you to have more than take 10K EPS, so more bandwidth if you need that. It also will provide with a level of failover. There are a few ways to do that. All of them are not based on Microsoft technology. I'm now suggesting things that you do using standard open source technology. A simple way to do clustering would be static distribution, deciding that a certain type of events go to a specific collector. That's of course easy, but it doesn't provide all the requirements you may have. One option that you have, which I feel might be the best today, is to use HA proxy. It's a very common open source load balancer that exists today on your Linux distribution. It's simple, it's free, it provides both clustering, so it will enable you to use multiple collectors without caring about static distribution. And it also enables failover, so you can have 2 HA proxies showing the same IP address, and if one fails data, the other ones capture the IP address and start receiving the event data. One thing to note about HA proxy is that it supports only TCP proxying, not UDP proxying, so you need to make sure that all your Syslog sources are capable of sending Syslog. An alternative to HA proxy would be a commercial load balancer. If you have one, it has a cost. It do roughly the same. I discussed Ceph and Syslog in length, and I sometimes differentiated. I sometimes just said Ceph or Syslog. It's worth noting the difference and what each one is. It's sort of important for the discussion. Syslog is the most common transport for sending, for managing events, originally in the Linux world and later on in networking and security systems. Ceph, common event format, is a structure over Syslog. So it essentially standardizes the payload, which is commonly used in the security world. It was developed by ArcSight around 20 years ago. And as you can see below, it provides a key value format that's used with the Ceph data. The main distinction is that Ceph is by definition pre-parsed. It has a very structured way of presenting name fields and values. When we get information using Ceph, it is stored internally in Sentinel in the Ceph table, and it's stored using field names. So it's indexed as it gets in. When we get Syslog data, on the other hand, we don't know what the structure here, and we'll store it with minimal parsing. The few headers available with Syslog would be parsed, but the main area here between, I guess, fake user and the end of the line would be stored as the Syslog message. It doesn't mean that it's just that. Sentinel allows you to parse on the fly as data is queried. So the fact that it was not parsed on ingest is not a blocker. Okay? But it means that a parser is required. If the data is already available in a known format, it's always better to use Ceph. This is an example, and since we are not getting into parsers today, I'll just present it sort of as is, of how you can parse a known syslog stream into fields and make it into a well understood and used data. If you're not accustomed to query time parsing, which is sort of a newer paradigm within the SIEM world, think about it as creating views. You create a function. The function behaves as a view or a virtual table, and when you query, when you search the next time, use the view rather than the original table, and with it you get all the parsed fields as if they were real fields. I did mention before that we collect remotely not just Syslog or Ceph, but we do roughly the same also for Windows Event Forwarding. This feature is in private preview, so you need to apply in order to use it. The reason is that this collector does not have the performance requirements that we are targeting, unlike the Ceph connector, which we feel is capable of providing the value you need. So when we'll add you to the private preview, we will discuss with you your speed requirements. The structure is roughly the same. It's a bit similar. We have the log analytics agent, the Windows version, installed on a Windows VM. This server serves as a Windows Event Forwarding Collector or WEC, and the log analytics agent knows how to forward events to Sentinel. Logstash. We discussed a lot about the agent, either Microsoft log analytics agent, either as a direct agent installed on a server or an endpoint, or when combined with a WEC or Syslog server to be a connector. We are fully aware that you might feel more comfortable with Logstash, which is a very common way to collect events. And therefore, we allow you to use Logstash as the collector. As you can see, if you are into Logstash on the right side, we have an output plugin that can talk with Azure Log Analytics or Azure Sentinel and can send the data to us. So if you today have a Logstash infrastructure, you can add sending events to Sentinel very, very easily. One advantage is it has, and sometimes your only choice today would be more input sources. If you want to read files or databases or message queues such as Kafka, using Logstash would be the preferable way today. Also, if you want to do event processing, it can be done with the agent using Fluentd capabilities. More people know how to use filters and groks, etc., within Logstash in order to process events. Example would be some pre-parsing or obfuscating a field you don't want to get to the cloud without being hidden beforehand. Lastly, custom connectors. You can, by the way, create a custom connector using Logstash. I described the event transformation capability, so it's one option. There are other options. Custom connectors are used to get events from sources that we don't support in any other way, but they're also very common in order to get enrichment data. You want to get GeoIP information or custom threat intelligence. I described last week are built-in or supported threat intelligence streams such as MISP or Sticks and Taxi. But if you have your custom threat intelligence, you want to build a connector to get it in, or asset information. All of those can be connected and collected using a custom connector. How do you go about creating a custom connector? PowerShell would be, all of them at the end of the day use the API. So behind the scenes, they're all API. We have a PowerShell module that knows how to send information to Sentinel. It's probably your easiest way to automate or to one-time send a file into Sentinel. Keep in mind that since Sentinel supports late parsing during query time, it doesn't really matter what the format is. We'll support it. If it's CSV or JSON or XML, then the parsing is built in. Anything else we saw earlier on how to create a parser. You can also use logic apps, which is, as you may recall, if you've been to the last week webinar, our automation engine. When we use it as an automation engine, we trigger it off an alert. When you use it to import information as a custom connector, it will be either scheduled to run every few minutes or hours or whatever makes sense for the source, or triggered off an HTTP request. So if the source knows how to trigger sending events, it can trigger the logic app automation. It has the capability to read files or databases or APIs, so it's an alternative to Logstash to read all those. And while Logic Apps is a cloud creature, it has an on-premise gateway, so you can use it to create a custom connector to collect data from on-prem as well. And of course, you can use direct APIs to create your custom connector if the need arises. If you feel comfortable with that. One thing to keep in mind that direct API use and programming doesn't mean you need a server now. All of those are supported in Azure Functions, so it can use serverless capabilities as well. So summarizing our on-prem collection capabilities, and I actually go to sort of the summary slide again. No. How do I get to my slides? Never mind. I won't go back. I'll summarize over this slide. We discussed that after discussing cloud collection, mostly mentioning it's very easy. Go to the documentation. I discussed in length our IaaS and on-prem collection capabilities. I mentioned installing agents on servers, which with the cloud becomes more the preferred way to do things because it ensures that your servers are monitored well also when they are auto-scaled, when they are more temporal. But we also have remote collection capabilities, such as using a Syslog collector, which is based off the agent and a Syslog server, or WEF for remote Windows event collection. As an alternative, I suggested Logstash, which we support and which will enable you to use technology you may know better to do additional work or use existing collection capabilities. Lastly, I discussed custom connectors, which is if nothing works otherwise, your way to make sure that you get the data gets in. Lastly, to summarize, keep in mind that not having a built-in connector is rarely a blocker because you don't have to pre-parse the data, which in traditional SIEM world is a major blocker. For us, the data gets in, and the change to support it would be changing an on-the-fly create time parser, which can be done after the fact once the data is already in. With that said, I'll move from collection, focusing on-prem collection, into our cloud architecture. It's a very different topic. It's sort of moving into another world. It has some touch points, but not a lot. If you're a SIEM guy, you might need an introduction to Azure to understand the rest. I didn't share my background. I am a SIEM guy. I spent many years at ArcSight, starting as a researcher, then a product manager focusing on products, and then I was the product director for EMEA, working a lot with customers in Europe, making sure that hopefully they're successful in implementing their SIEM. So I know a lot about SIEM, Syslog. I know the bits. Since joining Microsoft last year, I had to go through a journey learning Azure because it's cloud world, and you need to understand the cloud in order to not just run Sentinel. In order to monitor the cloud to start with, you need to learn the cloud. I'll give you an example, sort of not directly related here, but if you're into SIEM, you would know that the asset model is a very important part of SIEM, and it's about IP addresses and host names and subnets, and it's all irrelevant to the cloud. In a world where computing is either serverless or temporal, the way you define your assets and group them is very different. While a bit different between the cloud vendors, resource groups will be more important than VNets. So keep that in mind. You need to understand Azure, not just to run Sentinel, but in order to protect Azure. And you need to understand other clouds in order to protect them when you try to do that for you as well. So let's start. And again, it's not a comprehensive Microsoft Azure introduction. It's here to serve to describe how we manage the cloud estate with Sentinel. The first concept to understand would be the Microsoft tenant. A tenant is an authentication and identity management domain. It is actually the same as Azure AD instance. Usually, a tenant would correspond to an email suffix. So everybody at Microsoft.com is have the same suffix email address because we belong to the same tenant. It doesn't mean that all Microsoft resources belong to the same tenant. It means that all the mailboxes, so that Office 365, which we touched in a minute, is within the same tenant. Within a tenant, which is identity management space, we have something we refer to as subscriptions. Some of the subscriptions will represent SaaS solutions. Office 365 would be a subscription within a tenant. Dynamics, Microsoft CRM solution, would be another one. And Intune, while not a SaaS solution, also fits in within this model. Those would be usually one-to-one. There's one Office 365 subscription within a tenant. On the Azure cloud platform, you can have a lot of subscriptions. Subscriptions are the payment level for Azure. To have a subscription, you need either an enterprise agreement from Microsoft or a credit card or a free subscription. There are a few options available around that. So that's the level that has a paying owner. Subscriptions include resources, as you see at the bottom. Resources are the things you manage. I just mentioned them when I talked about an asset model. Resources might be VMs, that's the simple resources. There might be network elements in your VNet. There might be PaaS services, whether around IT infrastructure, so a firewall or a PaaS database, etc. All those are resources. Resources are managed in resource groups, which are an interim level between a subscription and resources. They are softer than a subscription because they're not attached to money. Money is always a very hard factor, but they enable grouping resources and managing them together. Think about them as folders of resources. One area where resource groups are very useful is in permission management. Permission is inherited in this model. You assign permissions on subscription level. You can modify them on the resource level, group level, and again on the resource level. Very much as you would in a Windows file system, for example. I'm ignoring for now the management group level. It's another level of abstraction to manage multiple subscriptions together. It's not heavily used. Sentinel, and the discussion is not a generic Azure discussion. We want to discuss Sentinel. Azure Sentinel is a resource. It's a resource within Azure. You can think it of as a database, or we call it a workspace, where everything to do with a single Sentinel deployment is consolidated, but it's managed in terms of Azure as a resource. So it's part of a resource group. It has permissions. It's indirectly part of a subscription, which is whoever pays for it. One important aspect we'll have to discuss when we talk about Azure and about Azure Sentinel would be regions and geos. Azure is deployed in data centers. Those data centers are mostly transparent to all of you. They are grouped into regions, which are sets of one or a bit more, 1 to 3, as I recall, data centers that are very close to each other and that provide redundancy internally. The map you see here is a map of Azure regions. You can deploy Sentinel in any Azure region that supports log analytics. There are exceptions. I probably should not have had this slide without listing the exceptions specifically because it tends to be a bit misleading. We are still not available in what we call national clouds, so China or US federal one, and there are a few other ones which are still missing. Naturally, if log analytics is not supported there, log analytics is, if you've been to my last webinar, or the infrastructure layer, but we have, with a few exceptions, we support wherever log analytics is supported. That said, we at this point in time do not commit to the data staying just at the region. We're working on a plan to have better support for that. But at this point in time, we commit just that EU data doesn't leave the EU, and that American data, US data, I should say, does not leave the US. We do not, data from the rest of the world is shared through the US. We understand that that's a limitation, that in many countries you will want to have the data not leaving your specific country, and we are working on a plan to provide that, but we are not there yet. Also in the EU, if you select any workspace in any region, data will still be shared with West Europe, which is physically in Amsterdam. Also, while I said data, as you can see in the slide, this is data at rest. Data in motion is a much bigger challenge, especially since we collect data. We found that it's pretty hard to ensure that if data flows between, say, UK West, if you install there, and EU West, which is Amsterdam, to know exactly what are the routes it follows throughout, so whether data in motion will ever leave the EU or not. It's something we work to investigate. It's a general Azure question, which we are looking into. Also, keep in mind that we have a lot of collectors. Those are collecting from external services, and that makes the question of where the data goes before it gets to Sentinel even more complex. So our commitments, as I described them, are for data at rest. As I mentioned, in the US, it stays in the US. In the EU, it stays in the EU, but may not stay in your country. And the rest of the world, it today goes to the US. So that was an Azure introduction with a bit of discussion of Sentinel around Geos. I mentioned that the main Azure Sentinel entity or resource will be the workspace. The workspace is a container. It includes most of what you think of as Sentinel. Keep in mind, as I mentioned before, today it's not a physical disk. So it may not imply that it's all in one place. It's a resource, as I said, in Europe, it's part of it will be in Amsterdam, even if you placed otherwise. But what's belong to that? What's part of that? The event database, rules, incidents, a lot of the data. Some other elements that we use as part of Sentinel are standalone Azure entities or resources and can be managed separately as far as permissions, for example, or deleting, etc. Two examples of those will be playbooks, which we use for automation, and workbooks, which we use for dashboarding. As I mentioned, our workspace is the same workspace that you may have been using with Log Analytics. In practice, Sentinel is a solution over Log Analytics. So any Sentinel workspace is basically a Log Analytics workspace with the security insight solution implemented. It does mean that whenever something is possible for Log Analytics, we are upward compatible. It's possible for Azure Sentinel. It's important because sometimes you'll go through documentation, you see that it can be done with Log Analytics, and you say, but what about Sentinel? That's granted. I mentioned workspace, and what we do find out, and a core of the rest of the discussion today would be around that, is that customers many times cannot have a single workspace for reasons that we'll discuss in a moment. The rest of the discussion would be around why you would need multiple workspaces, how many you would need, and how to manage multiple workspaces as a single Sentinel entity. Why multiple workspaces? So if you have multiple Azure tenants, you will probably need a workspace for Sentinel in each. The reason is that the Azure monitoring framework is very tenant-centric. So most sources would know how to send information only within the tenant. There's a good reason for that. Tenant is, authentication domain, and cross-tenant authentication may be challenging and open to exploit. So that's nearly mandates creating multiple workspaces. Another reason would be if you operate in multiple regions. There are two reasons that may want you to separate workspaces if you have multiple regions. One is compliance. You work across the ocean. You want to have the data in the EU staying in the EU, in the US staying in the US, and therefore you have two workspaces, one created in an EU data center and the other in a US data center. It also reduces networking cost and latency, because if your sources, whether on-prem or in Azure data center, or even in an AWS data center, are closer to someplace, it would imply that you have lower latency and pay less networking cost if you have an Azure Sentinel workspace close by. A last reason, which is somewhere between strong and soft, would be subsidiaries. We have solutions, and we'll talk about later, to have data from multiple subsidiaries in a single workspace. Sometimes the organization would prefer to have workspaces per subsidiary. There are other reasons that would drive you to have multiple workspaces, but we think that they are avoidable, and the workspaces may need to be consolidated. One is separate billing. A workspace is part of a subscription. Subscription is the payment unit, which sometimes leads people to want to separate workspaces for each subscription. We do not think this is best practice. It makes too many workspaces, which even given the tools I'll present later on to manage those, might become just too much. Next, there is fine-grained retention setting and fine-grained access control. In both cases, it's sort of a legacy reason until probably sometime last year. Retention setting and access control were sort of per workspace, and therefore you would separate between workspaces to provide access to different people or to set different retention setting. We've introduced a number of capabilities around retention setting and access control within a workspace that made those reasons much less important. And lastly, legacy architecture. For log analytics, which exists for a while, the guidelines initially were more workspaces, and with the introduction of fine-grained control, the tendency is to try to consolidate workspaces. So you just may come to an organization where, or your organization may have a large number of workspaces already there for different reasons. So as a rule of thumb, sort of how many and how much, I would urge you to use one workspace for each tenant you have to monitor, for each Azure region and for each subsidiary. It still considerably might be a large matrix, but not as large as we sometimes see today, where every subscription is a workspace. Also, if you don't have compliance reasons, if you may want to reduce further. This would imply, depending on the size of your organization, how many subsidiaries, how complex is the organization, anything between, well, one in the best case, a few in a reasonable organization, but it still can get to 15 or 20 workspaces easily. So the next step would be how to implement Sentinel across workspaces. The first step would be to consolidate workspaces, getting rid of the legacy reasons. Next, I will mention Azure Lighthouse, which you'll have to implement to provide cross-tenant access. It's not needed if all workspaces are within a single tenant. Then we discuss how to work cross-workspace with Sentinel, talking about queries, workbooks, configuration, and access control. Consolidating workspaces. So the important thing to keep in mind is that given how monitoring works, just moving things to a central workspaces is usually costless and easy. It's just a procedure in the organization. So taking the pipe from one pool and putting it in another pool would not cost you any different and will not affect your operations in any meaningful way. So it just has to be done. A special case I want to mention would be Azure Security Center. Historically, Azure Security Center is many times used with default workspaces, which are created per subscription. It's not needed in any way. It's not important, and you can use the data collection screen to use to point all Azure Security Center managed servers to send information to specifically selected workspace. Azure Lighthouse. Azure Lighthouse is a new technology that Microsoft introduced this summer, and it enables cross-tenant access. Behind the scenes, it's a user management scheme, but we support it, and we allow you, using once you implement Lighthouse, and you see on the right, if you know Azure, that and that's myself, that I have now access to 2 tenants at the same time. It means that everything to do with search, the log screen in Sentinel, and workbooks and hunting can be done across workspaces. As a tip, the query has to take into consideration the multiple workspaces. An easy way around that, I mentioned before a view, the concept of view for parsing, which we call functions in Sentinel. Those can be used also for multi-workspaces. So you can create a function that will represent any schema that's used within Sentinel, but built in would do it across all your workspaces across tenants. So any search, any workbook, so dashboard or hunting activity can be done across workspaces within the same tenant or across tenants. I did mention cross-tenant or cross-workspace workbooks. So all your monitoring functions can be extended across multiple workspaces. As I mentioned, as of today, it probably will require our out-of-the-box dashboards work with the current workspace, and you'll have to go and modify them. And the easiest way would be to create a function that replaces any schema with your extended cross workspace source, and then go to each one of the workbooks and change the queries to adjust. Some things that you may want to look into is cross workspace alert monitoring and connector status, things that we are starting to provide in a single workspace and have to be extended across workspaces. One thing I do want to mention, and I'll hint at the roadmap, even though it's a public discussion, there's one very important feature within Sentinel, which is not a workbook. It's the incident screen. It's the central screen that an analyst uses. It can be replaced by a workbook, but it has functionality that you would want to use. We are working to have a version of the incident screen that works across workspaces and tenants. Another challenge that multiple workspaces will present would be cross workspace management. We are in the cloud world. We are very much API driven. If you know Azure, you know that ARM is our way to provide DevOps with capabilities to scale. So ARM templates are a way to create any resource in Azure. Between APIs and ARM templates, we provide you all the tools to automate, to replicate content configuration across workspaces. So get it from one workspace, the master one where you work, and replicate to all the others. You'll need it, for example, for alert rules and hunting queries. And a big thanks to one of our partners, Vortel, that created Azure Sentinel, which is a PowerShell model that does that for you without you having to understand the API. You'll want to, if you have playbooks and workbooks that are specific to a workspace, you will be able to deploy them using ARM, and it carries also to things more granular, such as permissions. To sum it up, we don't provide today a UI-based option to manage across workspaces, but we do provide all the ways to automate or the replication of content configuration across workspaces, which we find in the cloud world is usually the norm, as it has to be part of a DevOps cycle. Lastly, an interesting and important aspect. One of the reasons for multiple workspaces, as I mentioned in the past, was access control, because you wanted the original resource owners to have access to their data. It's most notably important in the cloud world. You have people that managing a Windows Server farm, and you take the data from them, but they want to also have access to their Windows Server logs. As an alternative to using multiple workspaces, we have introduced data role-based access control, and it has two variants that might be useful to you. I'll start with the second one. It's more powerful, but it has its limits. Resource-centric RBAC. Resource-centric RBAC enable you to allow access to specific IT owners just to the data collected for their own resources. They don't have access to your SIEM, to Sentinel, but rather through the resource search screen itself, in the resource screen, they have a logs tab, and in the logs tab, they can search through their data. That carries also for resource group. It doesn't have to be resource by resource, and even to a subscription. So if they own the resource group, they can search through all the data that belongs to that resource group. It's a very powerful feature. Until recently, it was available only for Azure resources. Last week at Ignite, Microsoft introduced a technology called Azure Arc. Azure Arc enables you to extend these management features into on-prem or IaaS servers in other clouds. Now, any server can be assigned as a Sentinel, as an Azure resource, and therefore be managed from Azure, as well as have access control to the data to the resource owners. So now you have VMs on-prem. The same capability applies to them. You can provide access to their owners, to their log data, without providing them access to any other data or to the SIEM itself. The second option, table-based RBAC, enables you to control access to specific types of data within Sentinel. A good use case would be to limit access to Office activity logs. Office activity logs tend to be more sensitive than firewall logs, and you may want to say that to this data, you want only a fraction of the users to have access to. Trying to summarize the discussion around Azure Sentinel Cloud architecture. Sentinel is a workspace. The basic entity or resource which forms Sentinel is a workspace. It lives within a region in Azure. And while you would want to reduce the number of workspaces because it's just always harder to manage more and more resources, there are factors that would drive you to have multiple workspaces even in your organization. Those would be geographies, subsidiaries, or tenants. You may find yourself in a situation where, because you have a few tenants, a few geographies, and a few subsidiaries, you get to a substantial number of Sentinel workspaces. Whether 5 or 15 or 20 would be very specific to your organization. What I provided you today was with first the best practices, what you should split workspaces because of, and what you should probably avoid and use our more advanced capabilities to do using a single workspace, as well as a set of steps in order to manage a large set of workspaces or a set of workspaces as a single Sentinel entity. I focused on using Lighthouse to enable cross-workspace query search, workbooks, and hunting. I mentioned that we will develop also a cross-workspace incident screen, which is not available today. And then I mentioned how to centrally manage the content for those workspaces. And lastly, how to manage data access in order to provide with fewer workspaces still access to the data for resource owners. Before I move to questions, I want to remind you again that's a starting point. Actually, it's the second iteration. We discussed the basic functionality of Sentinel last week, and there's more that we'll share in upcoming webinars. There's a time until that next webinar. It's after the holidays. Meanwhile, we do urge you to join the community. We do answer. It's a very active community. Also, follow our tech blogs. We publish multiple times a week, a lot of new data. It's many people who do that. We have a growing community. Skipping the other links on this slide, I talked about community. You'll see that there's, well, I've been working with SIEM for a while. The rate in which we are building our community, and Ryan, thanks to you and your team for making that happen, is very fast. And we see meetups and blogs by others all the time, and we'd love to support you. So blogging is for you, but we'd love that. If you have a meetup, if you want people to hear about Sentinel, don't hesitate to contact us and we'll find the right way to support you on that. Thank you all. Ryan, do we have questions?
Yes. So I want to remind people here, now's a chance to submit additional questions, though we've been answering them in the IM window all along. Any of the ones submitted from now on we'll be reading out. So if you have a question that's, say, maybe more easily explained by a quick demo than by something we can type in a response, now is a great time for that question. And we can reach
Demo.
out.
I need to go to demo mode. Where is my browser? You put me on the spot for that. Anyways.
Sorry to do that. All right. So one of the questions we had come in is, how does Azure Sentinel monitor SaaS and PaaS services?
So a great question for a short demo, because you asked for that. So I did discuss in length how we collect from on-prem, because there's a lot of subtleties there, a lot of details. In a way, I sort of jumped through SaaS and PaaS services because it's easy, but it's worthwhile. So for example, let's take Azure Active Directory. It's somewhere between PaaS and SaaS. It's very fundamental, but it's a good starting point. I don't have permissions, but you'll see that all you need to do here is just to connect, and that's all. It's because we have the connectors behind the scenes. We are in charge of everything there. You have to do nothing. Let's move to something a bit more complex. Well, complex would be the wrong way. Let's look into Microsoft WAF. I tell you that I'm pretty fond of this one because it uses a rule set that I started developing as an open source project 15 years ago. I'm not that young. But let's go to the connector page. You see that this connector page is actually very typical of what you can do with most PaaS and SaaS services within Microsoft. You do nothing here. What you do here is you open the application gateway resource and you tell it to send data to us. That's the instruction here. There's nothing you actually do here. The only thing we give you here is monitoring on the left side whether we actually got events from there or not. So that would be a second one. The last one I'll show you, talking about PaaS and SaaS, would be Amazon Web Services. That's not within Microsoft anymore. It's a different cloud service, but it's not more complicated. There is not a lot more. The main thing here would be that you need to take our values. Interesting enough, my AWS best practices would were for Microsoft to open an account because we read the data for you, but you have to also provide your role, the one you created there, and together with those three details, we will collect the data for you. So yes, it's a bit of a magic. It's much simpler. That's why I didn't go into details here. And I hope it's the same for you. Let us know if it's different for you.
Great, thank you. We've got a question here for Windows machines that are not managed by AD. How would someone deploy an agent on those? Prerequisite, or do we have a solution for that?
So there's no requirement for being AD connected to install the agent. There is always, when something is not AD managed, there's always a question as how to manage its software lifecycle in the first place. How do you install an antivirus update, for that matter? So the agent itself would work very easily. It doesn't require any AD connection on any Microsoft Windows machine. How you actually go on installing would be depending on your alternative for software distribution, given you're not using GPO.
Okay, got it. What guidance do you have for people trying to use the API? Do we have any public documentation on that, or should people just be using the ARM API? How do they access that?
So API is a large word. I mentioned API in many different aspects in this presentation. I think the two main ones would have been API as part of custom collection for data ingest, and the second one would be API for remote for central management. The ingestion API is fully documented and heavily used. The configuration and management API, some of it is still in public preview, so might not be as documented as I would like it to be. For all, there is a API definition files, but sometimes not the level of documentation you would want. Between API and ARM, usually Azure Sentinel services are controlled by API. things which we use from the larger Azure ecosystem, such as workbooks or playbooks, are managed using ARM. Usually, it also implies better documentation. They are less new than Sentinel itself.
Got it. Thank you. We've got a question here. Can we also include Intune related logs in Sentinel, Azure Sentinel?
Yes. It's a good opportunity to go into our community blog and mention the blog post that I listed somewhere there. And by the way, talking about blog, you'll see that we published one on the 20th, on the 19th, on the 18th. We skipped the weekend, so it's a very active blog. That's what I'm trying to show. Thank you all blog contributors. If I take the connectors label and look just into that, I did mention that we have a blog post about collecting logs from Microsoft services. Because many of those know how to send to us, and you need the instructions somewhere to know how to do that. In this page, you'll find things such as, well, Intune down there, and that will lead you to the page in the Intune documentation tells you how to send to us information. And you'll see Intune is not an Azure service, but you see a lot of Azure services that you wouldn't know otherwise how to connect to us, as a Key Vault, Front Door, which is pretty new, etc.
Okay, great. Another question here. Is it best practice to have different Syslog and Ceph Linux VMs on-prem instead of combined? For example, we have many Cisco devices sending in Syslog and many Palo firewalls sending in Ceph.
So it's a bit, I'll put it this way. Okay, today, it will be easier for you to maintain two VMs because you'll have to manually change configuration in the collector in order to support both on the same box. It's doable, it's supported, but it adds a minimal level of complexity. For me, it's easy, so it's not fair. Therefore, I'll have to pick. Go with one, I'll tell you how to. If your organization is very structured and very towards just what's on the documentation, go with two.
Okay, great. What are the activities and data types collected by Azure Sentinel? Once I connect a source to Sentinel, any specific keyword that I should query in the log search?
I'll try. First of all, even though it's not apparent, it's important to know that Sentinel does support search. So you can actually use the word search in order to do a cross-source, cross-field, free-form search. It's not everything you asked for, but it's worth knowing that you don't need the schema to start. You have an IP address you want to look for, a username you want to look for, you can do a search and find them across sources. Secondly, the question is good, and the question is about documenting the schema or the events that you may get. We are working on that. There is a link which I don't remember by heart. It's on the GitHub where we collect all those. As usual, there's a lot that we get the events from sources. So a lot of the information about what we get is incorporated in the documentation for the sources, and we are doing the work of consolidating that and providing it to you. I hope that it will be ready shortly.
Excellent, thank you. Is there any way to hide sensitive information in the logs or events, say passwords or key pair values that get captured?
So I assume I'll say two things. One of them would be as a SIEM, as talking about Sentinel, the other is a SIEM guy. To do that, you'll have to use a collector. It works with Fluentd using a plugin, but there's less know-how about it. With Logstash, we have many customers who've done that. So by processing the events before they are sent to Sentinel. That actually works only for on-prem collection. There is a gap there, and we don't have a way to do it for the simpler cloud-based connectors. So that's that. The other thing that I do want to stress is that in general, it's very hard to ensure that when you collect logs in large volumes from multiple sources, there's no credentials in them if the source does not take care of that. Assuming that you always know where a password is hard.
Got it. Thank you. Can Sentinel run in one of the commercial Azure clouds but connect to and get log and security data from one of the government clouds?
I don't know. It's an interesting prospect. It would potentially work if a domain, so a tenant, can cross between the government cloud and a commercial cloud. I'm not sure that's the case. So I would say that for now I would use no as an answer, but it's probably worth looking into it a bit more, whether there's some way around that.
Yeah, I'll add to that. You know, a lot of the government clouds are very much their own specialty because, you know, each one can be so different and that it's hard to speak about them all in general. But we will be focusing more attention and resources on the government clouds that's speaking to that community. So watch our community closely over the next little bit for some government-related discussions and that sort of thing. I'll keep everyone posted.
And I'll add to that, I mentioned that we are not supporting government cloud today. We do work on that. So US federal cloud, to be more specific.
Perfect, thank you. Will Lighthouse eventually allow a single Sentinel instance to perform cross-tenant correlation and alerting?
So we are looking into that. We understand that's a requirement that's needed. That's a missing piece in supporting multiple workspaces. I don't have a timeline for that.
Okay, great, thanks. Let's see, when will the Sentinel Logic app trigger work on the rule templates? Oh, sorry, when will the Sentinel Logic app trigger work with the rule templates?
So I assume that the question is, and you know, I'll translate it. Today you can trigger off with the rule types. You can trigger off scheduled alerts, but you cannot trigger from the other types of alerts. I assume that's the question. We are working to ensure that Microsoft Security one, the fourth one, which is the most important one, most missing one today, is supported. It's work in progress. You know, I provide roadmap information. I'm not allowed to do dates, but that's closer than others.
Great, thank you. We're about out of time here, folks, so I'm going to give you a few links before we say goodbye.
Let me move back to the links so that you can talk about them.
Paste them in here also. If we did not get to your question somehow, or we missed it, or you're listening to this after the fact as a recording, please go to aka.ms/Azure Sentinel Community. That is a great place to ask a question. You're going to get all the same people who are answering on this call. So that goes directly to our engineering team. We always love to hear your feedback on the webinars, whether they're valuable to you and what we can do to improve them. So you can give that at aka.ms/security-webinar-feedback. If you're looking for recordings of any of our webinars and a list of upcoming ones, you can find that at aka.ms/security-webinars. You can join our community at aka.ms/security community. And the difference between that and the link I gave earlier about the Sentinel community is that Sentinel one goes directly to our Sentinel group. The security one at large is all of our security products. So you'll find links to all the security products there. If you are interested in getting in on some of the private previews, you can sign up for that at aka.ms/security private preview. I want to thank all the folks on our team who were answering questions today in the IM window. We really appreciate your help. Of course, I want to thank Ofer for a fantastic presentation. That was very informative. Most of all, I want to thank all of you for joining us and being part of our community. We will see you next time.